Welcome. The topic we will be discussing in this lecture is integer division. So basically in computer how the division is being performed. Okay. So that is what we are going to discuss and what is the circuit which helps to perform the division. So let us try to first understand how by hand division works. Okay. Then we will go for the actual implementation part. So here if you see there is a number 274 that is divided by 13. The result, the quotient is 21 and the remainder is 1. Okay. So that we are, so this is the 274 is represented here in binary. This is the dividend. Okay. This is the dividend. Dividend. Right. Okay. And this is 13 in binary. Okay. And this is the divisor. This is the divisor. So so first what we are doing is we are when you do 1 times of 1101 and if you see just the first higher order 4 bits, it is 1000, but actually this number is lesser than this. This 1000 is equal to what? 1000, the decimal equivalent is 8, whereas the divisor is 13. So you cannot subtract. Okay. So we take 5 digits. Okay. When you take 5 digits, then this will become 16. Okay. So now this is if you put apply 8421 code, this is in two positions. This is 4. Uh, sorry, this is 1, 2, 4, 8, and 16. Okay. So now it is something like from 16 you are subtracting 13. Okay. So that we have left this position. That is here you can assume it as 0. Right. So we are taking the first 5 digits. So this 1 you are keeping here and then we are subtracting. Okay. So 1 minus 1, 0. Okay. 0 minus 0, 0. Right. After that, what you should do? 0 minus 1. But how will you do 0 minus 1? You cannot do 0 minus 1, so you have to borrow. So there is a 1 here. If you borrow, the 1 can come here. So this will become 1, 0. But we want here. Okay. So again, from here if you borrow 1, this will become 1. And here you will get 1, 0. So 1, 0 minus 1 is 1. Okay, again this 1 minus 1 is 0. This has already become 0. Right? So when you divide, when you subtract this much from this is what you get, 100. Okay, but actually we need minimum 5 digits. Right? So 1, 0 you can bring by default. Okay, but we want to bring one more 0 also, so that we are adding this 0. Okay. Right. It is as if once again you are multiplying by 0 and again you are bringing another 0. Okay. That way also you can take. The principle is similar to the normal integer division. Okay. Again we perform 1 into 1, 1 into 1101. Okay. So again this is you have to take a 5 digit number. If you take 4 digit number, this will be smaller than this. Right. So again subtract 0 minus 1, we want to do 0 minus 1. So once again you have to carry, you have to borrow. So this will become 1, 0. Again this will become 1, 0. When that becomes 1, 0, this will become 1. Okay, again this will become 1, 0. Now this will become 1. Okay, or I will clear all other things. So when you borrow, first this will become 1, 0. Again when this borrows, this will become 1, 0, and this will become 1. Again when this borrows, this will become 1, 0, and this will become 1. Again, when the next borrow happens, this will become 1 0 and this becomes 1. Okay, so 1 0 minus 1 is 1. Again, 1 minus 0 is 1 minus 0 is 1. Okay, again 1 minus 1 is 0. 1 minus 1 is 0. This is already 0, right? Okay, so yes, so this is what happening. So next this one we are bringing down, but we also want to bring the another 0 also down. So if you want to bring this 0 down, then you have to add one more 0 to the quotient. Then again we perform multiplication with 1 and we got this. Okay, so now if you if you borrow, this will become 1 0. This will become 0. This will become 0. So 1 0 minus 1 is 1. 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 1 is 0. So the remainder is 1. So so the remainder is 1. This, if you convert to decimal, this is nothing but 21. If you see 8421 code, this one is 16 position. This one is in 4th position. Okay, this is in first. Okay, as per 8421 code. Okay, so 16 plus 4 20, 20 plus 1 21, right? So this is how it is done manually. Okay, fine. Now how it will be done through a circuit arrangement. So this circuit, if you see, it is very similar to the sequential circuit which we discussed for integer multiplication, right? So it's everything is same. Only thing is that carry part is not there. Here also we use the 4 registers: register A, Q, and register M. So register M will be holding the divisor initially, and register Q will be holding the dividend. Okay, A will be initially cleared to 0. A will be initially cleared to 0. Okay, so what you have to do is, first, immediately, these are the steps. So the first step is what you should do in the sense so A contains 0 and Q contains dividend. Just left shift the content of A. Okay, left shift the content of A, right? So why we are left shifting? So left shifting the content of A is equivalent to and finally, so once all operation is performed, finally register Q will be holding the quotient and A will be holding the remainder. Okay, Q will be holding the quotient and A will be holding the remainder. Okay, so when you left shift by 1, when you left shift by 1 time, it is equivalent to multiplying the number by 2. Okay, so left shift everything by 1. Okay, so all bits will shift to the left by 1. So this Q naught position, there will be an empty location created because everything you are shifting by 1. Okay, so Q naught will become Q1, Q1 will become Q2, so on and so forth. A n minus 1 will become A n, Q n minus 1 will become A naught, like that. Okay, so there will be a empty gap created in Q naught. Okay, but after shifting, what you have to do is, after shifting, uh, exactly what you have to do in the sense, you have to subtract the divisor. The divisor should be subtracted from A. Okay, so how will you subtract in the sense, actually we don't subtract, we add. We take the 2's complement of the divisor. So what we want to perform is, we want to perform this: A is equal to A minus M. That is, subtract the divisor from A and store the result in A. So this is equivalent to what? This is equivalent to A plus minus M, right? So this is what we are going to do. This is equivalent to A plus minus M, which means I can represent A as it is in binary, and I can represent B in the 2's complement, M in the 2's complement. Okay, so represent M in 2's complement, which is nothing but negative version of M, and then add with A. Okay, and store the result in A. That's what we are going to do. Okay, so the steps are, first left shift the content of A and Q, right? And then subtract m from a. Okay, so for subtracting, what we'll be doing is we'll be actually adding the 2's complement version of m with a, right? And store the result in a. And store the result in a. Okay, after storing the result in a, check the most significant bit of a. This is actually the sign of the number. This represents the sign of the number. Okay, this represents the sign of the number. So what you have to do is you have to check whether it is a negative number or a positive number. Suppose if it is a negative number, then there will be a 1 here. If there is a 1, then previously a space was created in Q0, no? This should be filled with 0. Okay, if it is a negative, that is if there is a 1, then fill this with 0. Okay, so then it means it is a negative number. It is a negative number. So in that case, you have to restore it to the original number. If it is a negative number, this number should be restored to the original number. How to restore that to the original number means just add again a with m. Just again add a and m. Okay, now we won't take 2's complement because this is addition, this is not subtraction. Again add a to m and store the result in a. And store the result in a. Okay, once again check whether this is and store the result in a. Yes, and store the result in a, and again left shift, and again left shift. Okay, everything should be left shifted by 1. Okay, after left shifting, again this q0 will be a space will be created. Now after left shifting, check what is in the most significant bit position. Is it 1 or 0? Okay, so if it is 1, again the same story. If it is 1, it is a negative number, so add m with a and store the result in a and do the same thing. If it is 0, if this bit is 0, then the q naught will become 1. Okay, if this is 0, then the q naught will become 1. Okay, right? Now we need not restore anything. Now we need not restore anything. Uh, if it is 0, the q naught will be if it is if it is 0, if this bit is 0, then q naught will become 1. Then q naught will become 1. Okay. Now we need not restore. Now again directly you left shift this entire thing by 1 and then repeat. Okay, how many times like this we do? How many times like this should we do? In the sense that depends on the number of bits in the divisor and dividend. If the number of bits in the divisor and dividend is n, this you have to do for n times. Okay, if the number of bits in divisor and dividend is 4, then this cycle you have to do for 4 times. Once you have completed this for 4 cycles, finally after fourth cycle, in A you will have the remainder, and in Q you will have the quotient. Okay, in A there will be remainder, and in Q there will be the quotient. Okay, fine. So these are the steps. What it says: shift A and Q left by one binary position. Subtract m from A. Subtract in the sense actually take 2's complement of m and add it with A, and place the answer in A. If the sign of A is 1, set q naught to 0. Okay, if it is a negative number, set q naught to 0 and add m back to A. It is restore A. Okay, otherwise set q naught to 1. Otherwise set q naught to 1. Repeat these steps for n times. Okay, n represents the number of bits, right? Let us discuss this with an example. Let us assume the divisor is double 1. Okay, that is if you want to convert to 4 digit, then 0011. Divided is 1000. Okay, so initially this is A. Okay, A will be what? A will be filled with zeros. Okay, Q will be what? Q will be dividend. What is dividend? 100, 1000. Divisor, this is m. This is m. Okay, so divisor is what? 0011, right? Okay, so what is the first step? Shift A and Q left by one binary position. So when you do that, what happens in the sense, this 0 will go out. This 0 will go out. This 0 will come here. This 0 will come here. Sorry, it's not that. A. We have to shift A. Okay, that is m. Sorry. This is m. Okay, this is m. We have to shift a. So when you shift a, this 0 will go out. Okay, this 0 will come here. Right? This 0 will come here. This 0 will come here. This 0 will come here. This 1 will come here. This 0 will come here. This 0 will come here. And this 0 will come here. Okay, so as this 0 is moved here, an empty position is created in Q. So that Q naught position is empty. Okay. Now we have to subtract. Now we have to subtract m from this shifted version of A. Okay. So so how do we subtract? Actually, we take 2's complement of m. What is m? M is 0 0 1 1. So take its 2's complement. Take 1's complement, that is 1 1 double 0, and add 1. So that is nothing but 1 1 0 1. Okay, it's a negative number, so its sign extension will be 1. Okay, so as it is a negative number, so it is 1 1 0 1, which is the 2's complement. As it's a negative number, we are adding another 1 here as a fifth bit. Okay, right? Now you just add, because adding minus m with a is equivalent to a minus m. Okay, 1 plus 1 is 0, carry 1, 1 plus 0 1. Okay, 1 plus 0 1, 0 plus 1 1, 0 plus 1 1, 0 plus 1 1, right? So now we have done the subtraction. Okay, and the result is placed in a. Now what you have to do, check the sign bit. If the sign of a is 1, then set q naught to 0. Okay, and add m back to a, otherwise set q naught to 1. So in our case, if you see, the sign of a is 1, so q naught will become 0. So this place previously which is empty, that we are now filling it with 0. Okay, if it is a negative number, then you have to restore the original value of a. Okay, so you have to add m to this. So this is the result. Add m to this. So when you add m, you will get this 0 plus 1 1, 1 plus 0 0, again 1 1 plus 0 0, again carry 1 1 plus 0 0, carry 1 1 plus 0 0. The final carry we ignore, right? So if you see this previous value, whatever is there, whatever in the previous case, I mean, sorry, whatever the previous case of a, immediately after shifting, okay, that same thing is restored here. That's what we are doing. Okay, if it is a negative number, we are restoring it. For that we are doing this. Okay, right? So so then, so after restoring, what you should do, again shift it to the left. So once again shift all these to the left. So when you do that, this 0 will go here, this 0 comes here, this 0 comes here, this 0 comes here, this 1 comes here, this 0 comes here, this 0 comes here, this 0 comes here, this 0 comes here, and here now a vacant is created, right? Okay, now once again subtract m, means that is take the 2's complement of m should be added. So this is the 2's complement of m. So this is the 2's complement of m. Add 0 plus 1 1, 1 plus 0 1, 0 plus 1 1, 0 plus 1 1, 0 plus 1 1. Now check the sign bit. Again it is 1. If it is 1, then that particular this should become 0. So it has become 0. If it is a negative number, once again you have to restore by adding with, what do you call, by adding with the m, that is the divisor. Okay, so again add 1 1. So 1 plus 1 0, I mean 1 plus 1 1 0, carry 1, 1 plus 1 1 0 plus 1 double 1, so 1 and carry 1, 1 plus 1 1 0, carry 1, 1 plus 1 1 0, carry 1, 1 plus 1 1 1 0, the final carry we ignore, right? Okay, so this again you shift left. So now 2 cycles completed. Third cycle, shift again to the left. So this 0 will go out, this 0 will come here, this 0 will come here, this 1 will come here, this 0 will come here, this 0 will come here. Okay, this 0 will come here, this 0 will come here, this 0 will come here, and here an empty is now created, right? Fine. Now once again add the 2's complement of m. So this is 2's complement of m. So 2's complement of m should be added. So 2's complement of m should be added with a. Okay, so 0 plus 1 1. So this is the 2's this is the 2's complement, right? 0 plus 1 1, 0 plus 0 0, 1 plus 0 0. Sorry, 1 plus 1, 1 plus 1 1 0, carry 1. 1 plus 1 1 0, carry 1. 1 plus 1 1 0 0, ignore that last carry, right? So you got this. Now see what is the sign bit 0. If the sign bit is 0, then if the sign bit is 0, then set q naught to 1. Okay. So if this is 0, so this q naught now it will become 1, right? Okay. Now you need not restore. Only if the sign bit is 1, you have to restore by adding m. Now we need not restore. Now third cycle is completed. Now we'll go to the fourth cycle. So what you have to do is now directly left shift. So this 0 will go out. This 0 comes here. This 0 comes here. This 0 comes here. This 1 will come here. Okay. This uh, yeah. So yeah, shift. Okay. So yes. So this 0 will come here, right? Okay. This 0 will come here. This 0 will come here. Okay. Actually, this 1 will come here, right? This 1 will come here, and here a empty position will be created. Okay. But anyway, we are not using this q part for adding. Okay. So it is not shown here, right? But actually, once you shift here, the this one supposed to be here, right? Here an empty should be created. Okay. Now again you subtract. Subtract means add it with the 2's complement of that. Okay. So this is 2's complement. Okay. This is 2's complement of m. Okay. So here you can see it is shown. Here the shifting is shown. Here there is an empty location, right? So actually it is shifted. So that this is what this, right? The add that with 2's complement of m. 0 plus 1 1, 1 plus 0 0, 0 plus 1 1, 0 plus 1 1, 0 plus 1 1. Again it is 1. It's a negative number. Okay. So if it's a negative number, then replace this q naught with 0. Okay. Here if it is 1, then here it will become 0. Now once again restore the number by adding 1 1. So you will get 1 plus 1 0, 1 plus 1 1 0, right? 0 and carry 1, 1 plus 1 1 0 plus 1 1 1. So 1 and 1, 1 plus 1 0, 1 0 carry 1, 1 plus 1 1 0 carry 1, 1 plus 1 1 0, and ignore that 1. Okay. So now after doing, because here if you see there is 4 digits, that's the 4 digit maximum. You have to take which number is having the maximum digit out of divisor and the divided. So here divided has the maximum digit, that is 4. So you can stop it by 4 cycle. So at the end of 4th cycle, whatever there in Q, that is the quotient, and whatever there in A that is the remainder. Okay. So this is how this algorithm works, right? Fine. Okay. So here if you see there are the number of steps are quite more. Is there any way to reduce the steps? Okay. Uh, yes, there is something we can do. So whenever there is a negative number, we are restoring. Okay. Whenever after shifting and subtracting m, if the result is negative, then we are restoring a. Then we are restoring a by adding m to a. Okay. But this restoring can be avoided. Okay. This restoring can be avoided, or what you can do is you can this instead of restoring, you can do something else so that the restoring can be without performing restoring also, you can effectively perform the division with a lesser number of steps. So what is the intuition behind that? In the sense, if a is a positive number, here in this case what we are doing, if a this is a at one point, it's a positive number, because this is sign bit is 0. If a is a positive number, okay, what we are doing, we are just uh, I'm not talking about replacing q naught with 1, okay, that is going on, but other than that what you are doing, if it is a positive number, then we just left shift, we just left shift a by one position and we subtract m from a, okay. Left shifting is equivalent to multiplying the number by 2. So this is a, right? Left shifting is equivalent to multiplying the number by 2. So after, if this is a, after left shift it will become 2a, okay, and that is being subtracted by m from m, okay, that is m is subtracted from that, okay. So basically the operation here done is 2a minus m. What you are doing is 2a minus m, this is what you are doing, okay, because a is the actual number, you are left shifting. Left shifting means it is equivalent to multiplying by 2, okay. Then what you do, you subtract m from that, so which is nothing but 2a minus m, okay. So that's what this statement says. If a is positive, we left shift and subtract m, okay, we left shift and subtract m, that is 2a minus m, okay. If a is negative, else means what? If a is negative, okay, if a is negative, then what we do, then we restore a. First we restore a. See here the case of a negative. So this is a case where a is negative, okay. Here whenever a is negative, first we restore a by adding m to this. So this step is equivalent to what in the sense? This is equivalent to performing a plus m. This is equivalent to performing a plus m, right? Because this is a, this is a, this is m. So that we are adding a and m. That is nothing but a plus m, okay. After that what we do, we left shift a and then we subtract m, okay. So left shifting a is not, so now this is the new a. After restoring a plus m, whatever you get, that is the new a. This new a is left shifted by 1, that is then it is become 2a, 2a and m, which is same as 2a minus m, the first case whatever we have discussed. So this is nothing but 2a minus m, okay, 2a minus m, right. So if a is negative, these two things we are doing. First a is added with m, okay, and then the result is shifted to the left and subtracted by, and m is subtracted from that, that means we are doing 2a plus m, okay. But these two steps, so we are doing this a plus m and 2a minus m, okay. These two steps can be combined together into one step. These two steps can be combined together into one step, okay, and this two step will just become 2a plus m. Instead of performing a plus m and 2a minus m separately, we can combine these two steps into one step, which is nothing but 2a plus m. But you may ask, how this 2a minus m and a plus m will become 2a plus m, okay. For that, let us discuss an example, okay. So this is a, right? Here it is understood that a is a negative number. You see how I am saying this is a, right? A is a, because the sign bit is minus, okay. So it's a negative number, right? Okay, fine. So or otherwise you just take from here itself. This number is what? This is 0001. So it is just 1. It is just 1, okay. And what is our divisor? So divisor is m. This is m in 2's complement form, okay. Okay, m in 2's complement form. We are subtracting m. M is what? 3. So this is 1 minus 3. Actually this is 1. This is minus 3. So when you perform 1 minus 3 here, what you get? A is minus 2. A is minus 2. Okay, just remember at this point A is minus 2. Okay, so this is nothing but 2's complement version of minus 2. You can convert this and check whether it is matching or not. It will match. Okay. So if you represent 2 in 2's complement form, then this will be like that, right? Okay. So this is minus 2. Now you are adding minus 2 plus m. So m is what? 3. M is what? 3. So 2 minus, so when you add minus 2 plus m, what happens? Minus 2 plus 3 is, this is minus 2, okay? This is minus 2. Minus 2 plus 3 is 1. This is 1, okay? This is, so you, here you got 1. At this step you got 1. Now you are left shifting this by 1 time. So left shifting, as already we discussed, it is equivalent to multiplying by 2. So that means 1 into 2, this is 2. This is 2, okay? Then we are subtracting m. What is m? 3. So that is 2 minus 3. 2 minus 3 is what? Minus 1. Minus 1, okay? So basically here in this whatever from here to here, what you are doing is, originally this is minus 2, finally it has become minus 1, right? So, so originally a is what? Minus 2, okay? From that we restored to 1 and then we subtracted minus 3. I mean, then we subtracted 3 and we got minus 1, okay? Okay. So what I am saying is, here we perform two steps. This two steps is equivalent to one step, which is 2a plus m. Here you apply 2a. This is a, okay? 2a is, a is minus 2. 2a is into 2, which is minus 4. Which is minus 4, okay? M is always 3. M is always 3. So minus 4 plus 3 is what? Minus 1, okay? So like that you can check for any other combination also. Here also, in this case also you can check. Okay, it will work. It will work, right? So from this, what you can infer in the sense, instead of going for these two steps, like when a is negative, first restoring by adding m and then shifting, okay, that is shifting is equal to multiplying by 2, again subtracting m. Instead of all these things, we can just perform one step, 2a plus m, okay? So if you do that, the number of steps will be reduced, okay, right? So now we can refine the logic. If a is 0, what you do, I mean, if the sign bit of a is 0, as usual you perform 2a minus m, that's it. If the sign bit of a is 1, then you perform 2a plus m, that's all, okay? Then you perform 2a plus m. So this is the logic, okay? So this is the algorithm. If the sign of a is 0, shift a and q uh, left 1 bit. So shifting is nothing but what? 2a. When you shift, it becomes 2a, okay? Previously a, it will become 2a. When the sign is 0, subtract m from a, okay? Otherwise, if the sign is negative, then shift a and q. Shifting is nothing but 2a and add m to a, okay? And add m to a, okay? After performing this, after shifting a, I mean, after checking whether the sign is 0 or 1, if 0, then shift a and q and and subtract m. If a is 1, then shift a and q and add m, okay? After doing this, again you check what is the sign of a. If a is 0, set q naught to 1. If a is 1, set q naught to 0. It is same as that of the previous algorithm, okay? So this should be done for n times. This you repeatedly do for n times, okay? But at last, you have to perform one more step in the second algorithm. This will not be done repeatedly. Only step 1 will be done repeatedly. These two things should be done repeatedly for n times. After finally, after completing all the n rounds, you check what is in a. So a will be holding the remainder and q will be holding the quotient. Okay, if a is a positive number, you leave as it is. Okay, but if a is a negative number, that is, if the sign of a is 1, then add m to a. That will be the final remainder. Okay, so at last this you have to check whether the number in a is a positive number or negative number. If it is a positive number, leave it as it is. If it is a negative number, then add m to it so that you will get the actual remainder. Okay, fine. So let us see that version also. So initially this is a filled with zeros, okay, and this is q. Okay, what is q? So so if you go back to our example, yeah, q is this 1000, okay, the dividend, okay, divisor is 0011, right? Okay, so this is q, okay, this is q, right? So first and this is the divisor, 0011, okay. So we added this one more zero for sign bit, okay. Actually it's a 4-bit number, but the last zero is added for sign bit. So first thing what you have to do is shift this by left by one time, a and q. So this go zero will go out, this zero will come here. So you know all these things, this will come here, this will come here, this will come here, this one comes here, this zero, this zero, this zero, and here a space is created, okay, fine. So now you have shifted to the left, okay, and subtract m. Shift to the left and subtract m. That is, take 2's complement of m and add it. This is the 2's complement of m and add it. 1 plus 1 0, carry 1 plus 1 1 0, 0 carry 1, 1 plus 1, sorry, 1 plus 0 1, 0 plus 1 1, 0 plus 1 1, 0 plus 1 1. So see the sign bit, it's 1, so it's a negative number. Okay, if it is a negative number, then the q naught should be replaced with 0. Replace it with 0. Okay. If it is a negative number, what should we do? See the algorithm. What you have to do? You have to perform 2a plus m. No. If it is a negative number, you have to perform 2a plus m. 2a means what? Shift to the left. 2a means shift to the left. So shift all these things to left. This one will go out. This one comes here. This comes here. This comes here. This 0 comes here. This 0 comes here, this 0 comes here, this 0 comes here, this 0 comes here. Here a space is created. Okay. And now add m. So whenever you say add, don't take 2's complement. Just add m as it is. 00011, add 0 plus 1 1, 0 plus 1 1, 1 plus 0 1, 1 plus 0 1, 1 plus 1, 1 plus 0 1. Again 1. Again 1. So if it is 1, then replace the respective q naught with 0. Okay. Again, if it is a negative number, once again perform 2a plus m. So 2a is what? Just shift to the left. So this one will go out. This comes here, this comes here, this comes here, this comes here. This 0 comes here, this 0 comes here, this 0 comes here, this 0 comes here, and here an empty position is created. Okay. And add m. M is normal m, no 2's complement. Whenever add, use the normal m. 0 plus 1 1, 1 plus 1 1 0, 0 and carry 1. 1 plus 1 1 0, again 0 and carry 1. 1 plus 1 1 0, again 0 and carry 1. 1 plus 1 1 0, so 0 carry 1. So ignore this last carry. So now if you see the sign bit, it is 0. Okay, if the sign bit is 0, then what should you do? You have to perform 2a minus m. If it is a positive number, you have to perform 2a minus m. 2a minus m means what? Shift to the left and add 2's complement of m. Okay, that is called a subtraction. So this 0 will go out, this comes here, this comes here, this comes here, this 1 comes here, this 0 comes here, this 0 comes here, this 0 comes here, this 1 comes here. Here an empty position is created. Now mention m into its complement and add. 0 plus 1 1, 1 plus 0 1, 0 plus 1 1, 0 plus 1 1, 0 plus 1 1. Again it's a negative number, so replace the q naught with 0, right? But already we have done 4 cycles, so stop, it's enough. Okay, because you have to do depending on the number of bits. Okay, finally you see what is in q in a, is it a positive number or a negative number? This is at last you have to check this. If it is a positive number, you can leave as it is. If it's a negative number, then finally what you have to do is add m to a. Add m to a. Okay. So that is what we are doing. So you take this, whatever this value in a. This is a. Okay. Add m to this. What is m? 00011. Right. So 1 plus 1 0. 1 plus 1 1 0. Carry 1. 1 plus 1 1 0 plus 1 double 1. So 1 and carry 1. 1 plus 1 1 0, so 0 carry 1, 1 plus 1 1 0, 0 carry 1, 1 plus 1 1 0, 0, and the last one ignore. Okay. So finally this will be the remainder. okay, and whatever is in the Q, that is the quotient, okay. So this is how the division operation can be speed up. So this is called as non-restoring division, okay. The previous one is called as restoring division. So this non-restoring division is an improved version of the restoring division, okay. Fine. So that's it about division. I think it's clear, okay. So let us stop here. Thank you.